These are the answers to the sample practice exam, Math 60, City College of San Francisco, Exam 6, scheduled for Friday, April the 3rd, 2020. Question number 1. Simplify the expression x squared minus 1 over x squared minus 5x minus 6. Do not cancel, for instance, the x squareds immediately. You might recall we are not allowed to cancel once you have a minus or a plus symbol. We have to factor instead. So you factor the numerator. This is the difference of two squares. So that's x plus 1, x minus 1. The denominator, x squared minus 5x minus 6. This minus sign means the signs are opposite. And so you want two numbers that have a sum of negative 5 and a product of negative 6. That would be x minus 6, x plus 1 here. The x plus 1s can cancel, so the final answer is x minus 1 over x minus 6. Once again, you're not allowed to cancel the x's here. Once you add or subtract something in either the numerator or the denominator, you cannot go any farther. Number 2, you have this division problem, and you might recall if you divide by a fraction, you invert the second fraction and multiply. So notice the first fraction we left alone, and you multiply by the reciprocal of the original of the second fraction. Now we have a lot of factoring. So 3n squared plus 5n minus 2 factors into 3n minus 1, n plus 2. 12n squared minus 13n plus 3 factors into 4n minus 3, 3n minus 1. You notice that a plus here and a minus here means the two signs are both negative. 4n squared minus 5n minus 6 factors into 4n plus 3, n minus 2. N squared minus 3n plus 2 is n minus 1, n minus 2. Obviously, when you factor, you might not get it this quickly. It might require some trial and error until you finally come up with the right combination. Recall that any factoring problem, you can always double check by multiplying this back out with FOIL, for instance. For instance, if you multiply this back out with FOIL, you should get this. If you multiply this thing back out, you should get this, and so on. Then you cancel factors which are the same in the numerator and denominator. Here in red, the n minus 2's cancel out. In green, the 3n minus 1 cancels out. And nothing else is the same, so we leave n plus 2 and 4n plus 3 on top. 4n minus 3 and n minus 1 stay in the bottom. Number 3, the first thing you want to do here is to factor y squared plus 4y plus 3 into 2 over y plus 1, y plus 3. So that means right over here we need a common denominator. This side has y plus 3, this side has y plus 1, y plus 3. So to get a common denominator, you need to multiply the numerator and denominator of the first fraction by y plus 1. So now we have a common denominator. We're allowed to add the numerators. 1 times y plus 1 is just y plus 1. And then I add that 2 there. And y plus 1 plus 2 becomes y plus 3. And then notice that this y plus 3 can now cancel this y plus 3, leaving us a 1 in the numerator. So the answer is 1 over y plus 1. Number 4, back up here, this complex fraction, the way to make it nicer is to multiply the numerator and denominator by the common denominator of x squared and x and another x squared and x. So I multiplied the numerator and denominator by x squared here in red, which will knock out that, and that. And then we distribute, which is what I'm trying to illustrate here in red. X squared gets multiplied by this fraction, this fraction, this fraction, and this fraction. X squared times this fraction, the x squareds just cancel out, leaving us with 2. X squared times 1 over x, this x will cancel this x, but that leaves me one more x times the 1 is x. Then over here, x squared times 1 over x squared, well, the x squareds just cancel out, leaving me with a 1. And 2 over x times x squared, one of these x's will cancel one of these x's, and then I just have an x times a 2, or 2x. So my answer is 2 plus x over 1 plus 2x. And once again, don't try to cancel the x's or the 2's. You're not allowed to once you have an addition or subtraction. Problem 5, treated as two division problems. 4x squared minus x cubed over 8x. You can do this right here, 4x squared over 8x. Well, 4 over 8 is 1/2, but we don't write the 1 because you're going to end up with 1 times x. We just leave it as x. So I have a 2 in the denominator. And then x squared divided by x is just x. So the first fraction is x over 2. And then I ignore this and I do negative x cubed over 8x. Well, the 8 just stays in the bottom. X cubed divided by x is x squared. So we have x over 2 minus x squared over 8. Number 6 is long division. So 8x cubed minus 1. Notice in setting up the long division, if it jumps straight from 8x cubed to negative 1, we have to put 0x squared plus 0x minus 1 in order to properly do the long division. So 8x cubed minus 1 is 8x cubed plus 0x squared plus 0x minus 1. Then I divide the 2x minus 1. Now we look at this, and we ask how many times does 2x go into 8x cubed? Or what do I multiply 2x by 8x cubed? The answer is 4x squared. So 4x squared goes here in the x squared column. Now you take that 4x squared and multiply it by this whole 2x minus 1. 4x squared times 2x is 8x cubed. 4x squared times a negative 1 is negative 4x squared. Then we subtract. You may recall that's exactly what we did with long division of numbers. So put parentheses, subtract 8x cubed minus 8x cubed is nothing. 0x squared minus a negative 4x squared is a positive 4x squared. Bring down to 0x and repeat the process all over again. So just look at the first thing here and the first thing here, and we ask, what do you multiply 2x by to get 4x squared? The answer is 2x. So we put a 2x on top. Now you take 2x times this entire expression here. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Put parentheses, subtract. 4x squared minus 4x squared is nothing. 0 minus a negative 2x becomes a positive 2x. Bring down just negative 1. Repeat the process all over again. So first thing here, first thing here. What do we multiply 2x by to get 2x? Well, that's 1. So put plus 1. Now we take 1 times this entire expression, but 1 times anything is just that expression. So we put 2x minus 1. Subtract 2x minus 1 minus parentheses 2x minus 1 gives us no remainder. So the answer is just 4x squared plus 2x plus 1. Question 7. We want to simplify the fractions, clear the fractions. So before we get started, multiply by the common denominator of 2x. I see a 2 here and an x here, so that led me to multiply this side by 2x, this side by 2x to clear the fractions. Now 2x times this fraction, the 2's cancel out, so I still have the x times the x minus 1. Then I have 2x times 1, which is just 2x. And then on this side, the x's cancel out, leaving me with 6. So I have this equation which no longer has fractions. Distribute x squared minus x plus 2x equals 6. That's going to give me a quadratic equation because there's an x squared. So I want 0 on the right hand side. I subtract 6 on both sides. Combine like terms on this side. We have x squared plus x minus 6 equals 0. We factor. The minus sign means the signs are opposite. And there's a 1 here. So I want two numbers whose product is negative 6. And when you add them, you get 1. That would be a positive 3 and a negative 2. So x plus 3, x minus 2. Then by the zero factor property, either this expression is equal to 0 or this expression is equal to 0. Remember, we did the shortcut in class. We really asked what number do I plug in to force this expression to be 0. That would be negative 3. And likewise, what number can I plug into here will give me a 0, and the answer is 2. So my two solutions are negative 3 and a positive 2. Up here, Q equals A plus I over L. We're trying to solve for A. So first let's get rid of the L by multiplying both sides by L. L cancels out here. That gives me QL equals A plus I. We're trying to isolate the a, so I want to get rid of the I. I just subtract I on both sides, giving me QL minus I equals a, or since we normally have the variable that we're solving for on the left-hand side, a is equal to QL minus I. In question 9, John can do the entire job in 6 hours, Mary can do the entire job in 3 hours, and they're helping each other. And let x be the combined total number of hours. So if we consider 1 hour of work, if John works for 1 hour, he will have completed 1/6 of the job because it takes him 6 hours to do the whole job. Mary, in 1 hour of work, can finish 1/3 of the job because it takes her 3 hours to do the whole thing. And by the same logic, the combined total would be 1 over x. Notice we just take the reciprocals here, 1 over 6, 1 over 3, 1 over x. Those jobs combined, the 1/6 contributed by John and the 1/3 contributed by Mary is equal to 1 over x, 1 over the total. So we have 1/6 plus 1/3 equals 1 over x. Multiply both sides by the common denominator of 6x. 6x times all of this, 6x times this. Here the 6 cancels out. I have x times 1, which is x. Here 3 goes into 6 2 times, so I have 2 times x times 1 is 2x. And on this side the x's cancel out, giving me 6. Giving us 3x equals 6, or x equals 2 hours. So working together, John and Mary can finish the job in 2 hours. Finally, number 10, the best way to do this problem is to cross multiply. You might recall if you have an expression that looks like a fraction equals a fraction, we're allowed to cross multiply, which means this times this is equal to this times this, which is what I'm indicating here with a cross. It's called cross multiply. So that times that, 5b plus 4 times 5, which is 20, is equal to 3 times 3b minus 6. 3 times 3b is 9b, and 3 times negative 6 is negative 18. Right, so I want to get I want the b's on the same side, so I subtract 5b on both sides. While I'm at it, I'll add 18 to both sides. So these will cancel out, these will cancel out. So I have the b's on the right-hand side, the numbers on the left-hand side. That gives me 38 equals 4b. Divide both sides by 4, and that leaves us with 19 over 2. So this is the practice test. And of course, if you can't see this, because the way I have it set up, it might be a little bit small. Ideally, you have the test and this sample in front of you, full size, so you can just follow along from there as I point to different parts of the exam.